Now see how can we do this question. First of all, we should see that they have asked for the voltage across in resistor. Okay, this time they don't ask the current across inductor or the voltage across inductor. This time they have asked the voltage across resistor. Okay, but still for voltage across resistor we should know the value of current across inductor. Then we can apply the KVL. Okay, like simply they said na at t equal to 0, so at t is greater than 0, this switch is opened or closed? Tell me. At at t equal to 0 minus, switch is opened or closed? First tell me about the first switch. T equal to 0, it is open, it was, so first switch is closed and another switch is opened, right? Similarly at t equal to 0 plus, this switch is opened and this switch is closed, right? So they are asking for t is greater than 0, so t is greater than 0, first switch is opened, then the diagram would become like this, right? So they want the voltage across resistor, right? And according to Ohm's law, V is equal to I multiplied by R we already know. We can simply apply KVL in this equation, okay, in this mesh. But for KVL we should know the value of current across inductor, right? So that's why we'll calculate the current across inductor. Understood the question? That why we are calculating the current across inductor? They didn't ask you the current across inductor, but we have to calculate for the voltage. Okay, now similarly again, what was our first step? At t equal to 0 minus, that is the condition of steady state. At t equal to 0 minus, first switch is opened or closed? Closed. And the second switch is opened. Okay, this is closed, this is open. Again inductor will behave as a short circuit, correct? If there is no connection over there, then there is no role of this source, I'm deleting it. Okay, now simply we need to calculate the current across inductor. This is simply a one mesh, I1, right? I1 we can say it by V by R. V is 8, R is 1 kilo ohm. 1 kilo ohm means 1000 ohm. So that would be 8 milliampere, right? Okay. Now again we'll do the another step. At another step, at t equal to infinity, again the steady state condition. Now tell me at t equal to infinity, this switch is opened or closed? And this one? Okay, if this is open then there is no role, so I'm deleting it. Okay, again inductor will behave as a short circuit because this is the condition for the steady state, right? So again we need to calculate the current across inductor at infinity. How much? Tell me, how much would be the current? Yeah, that would be simply we can apply Ohm's law. Vi is equal to V by R, right? V is 10 volt and R is 500 ohm. So 1 by 50 means 20 milliampere, right? So we got it as I infinity as 20 milliampere. Next step, step number third, at t equal to 0, that is at transient, right? Now tell me, this switch is opened or closed? So for this, again, there is no role of this voltage source, so we have to delete. And inductor would be open circuit, right? And we have to mark A and B terminal for R equivalent. And again, if there is a voltage source must be short circuited. Remember, current source open and voltage source short. So there is only single resistance. R equivalent we got it as 500 ohm. Now we need to calculate tau. Tau is L by R equivalent. L is how much? 10 millihenry. 10 into 10 raised to power minus 3 divided by 500. How much? Tell me how much we got it. 20 microsecond. Second, its unit is second. So we can simply put it in IT equation, that is I of infinity plus I of 0 minus I of infinity e raised to power minus t by tau. I of infinity, how much we got it? No, that was I of 0. So how much we got it? I infinity 20 milliampere. Okay, 20 milliampere plus I of 0 we got it as 8 minus 20 e raised to power minus t by 20 microsecond. Okay, if we'll solve it, we'll get 20 plus 12 e raised to power minus 20 t by 20 is, so if we'll solve it, we'll get 50 kt milliampere. So it is 8 minus 20, that would be minus 12, correct? So the final answer is 20 minus 12 e raised to power minus 50 kt. But this we got as I of t, right? What they want from the equation, from the question, V of t, right? Again we need to calculate V of t. For V of t, for t is greater than 0, this switch is opened or closed? And this switch closed. If it is open, there is no role, right? So can we say that voltage, total voltage is how much? 10 volt. That would be the voltage drop across a resistor, voltage drop across inductor, right? According to the Kirchhoff voltage law, VR is the voltage drop across resistor, that is I multiplied by R, or we can simply say VR. VL is how much? What is the formula for the VL? L di by dt. So VR is equal to 10 minus L di by dt. 10 minus inductor is how much? 10 millihenry. D by dt. Current equation we got it. 20 minus 12 e raised to power minus 50 kt, right? Got it? If we'll solve it, we'll get the final value. That would be minus 10 plus 6 into e raised to power minus 50 kt. Okay, because this one is constant, constant differentiation is 0, and if we'll further solve it, then we'll get this value. Okay, now we have to draw the graph also. So Vt we got it as minus 10 plus 6 e raised to power minus 50 kt. So this is the final value, right? V infinity, and we got it as a if we want to calculate initial value, what would be the equation? V of t is equal to V of infinity plus V of 0 minus V of infinity e raised to power minus t by tau, right? V infinity we know, that is minus 10, plus V0 we don't know, but we combine know it is 6, right? If V infinity is minus 10 and V0 minus V infinity is 6, can we get the value of V0? That is V0 is minus of minus 10 is equal to 6, that is 6 minus 10, we got it as a minus 4. So we got it V of 0 as minus 4, right? So we have to draw the graph also based on this. Initial value is how much? Minus 4. Yeah, and final value is how much? Minus 10. So it is minus 10. So our graph start from minus 4, it will go up to minus 10. Okay, got it? If you don't understood this, I'm repeating. V of 0 minus V of infinity is 6, right? So V of 0 is equal to 6 plus V of infinity, right? 6, 6 we get it from the equation. See, we can compare it with this now. V infinity is this one. So V infinity is minus 10. We got it as minus 4 V of 0. Why we have calculated all this? Because they also said that draw the graph. For the graph only we have done it. Okay, understood?